Another term you all should know. So of the components of blood, give me those components again. Plasma and informed elements. Right, plasma informed elements. So what if you wanted to get a person's blood and all you want though is their cells? You don't want the plasma. How do you separate them? By centrifuge, right? So that's what's shown here. This is a centrifuge, a little machine. Yes, that's what a centrifuge is. So you put the blood in the tube, put the tube in the centrifuge, and there are wells that kind of, the tube goes in at an angle like this, so when it spins very rapidly, everything heavy goes to the bottom. So in whole blood, the heaviest part of the blood are the red blood cells. Okay. So the red blood cells end up sinking to the bottom of the tube. And if you just want plasma, you can get that off the top.
How do they?
Hematocrit is referred to as packed cell volume. Centrifuge blood to separate the components. Erythrocytes, again, are the heaviest, so they settle at the bottom. And in whole blood, the normal amount that you'll have of red blood cells in whole blood is 37 to 52% by volume. So that would be called your hematocrit. So your hematocrit is the percentage of your whole blood that is red blood cells. The percentage of whole blood that is made up of red blood cells. And for a person who is normal, it's going to be somewhere between 37 and 52%. Men have a slightly higher hematocrit than women, and we'll see why later. Okay? So if ever your blood is analyzed and your red blood cell count is above 52 or below 37, then there's something probably going on there. Okay? So that's the norm. Leukocytes and platelets are also here. They're in this area called the buffy coat, and it gives a whitish appearance. So, but there's a very small amount of white blood cells in whole blood. You'll notice here. So, if this is your whole blood, a very small amount, less than 1%, is going to be made up of white blood cells.
Why isn't it bigger if the leukocytes are supposed to fight off like pathogens and stuff? Why is it so?
Well, when you'll notice if a person has an infection, it increases. So white blood cell count increases during infection.
So they do like a helper T cell type of thing.
Yeah, they can look at those also. But also keep in mind, if for some reason there's an abnormally high white blood cell count, infection is probably the primary cause. And if no infection is there, or if the white blood cell count stays elevated, then they look further. And if it's very elevated, it could be leukemia, which means they're producing too many white blood cells. And that's, of course, a form of cancer.
So, Dr. Wilson.
And in plasma. So plasma, again, is the extracellular material of blood. And so there are different substances dissolved in the plasma. But the three major categories of proteins that are there, you all should know these by name. Albumin is the most abundant type of protein that we have in our blood, okay, in our plasma. And albumin you've heard of before, and the type of food we eat. What food is albumin? Liver, okay. What else? What about a breakfast food? Eggs. Right, egg white is albumin. That's the good part for you. Yeah. Egg white is good. The yolk is what's bad for you. That's cholesterol. Globulins, which are also antibodies, and then fibrinogen. So these are the proteins, major proteins found in blood. And this is just another view, composition of whole blood. So again, you can spin it down, and the formed elements sink to the bottom. Why? Because they're heavier. And the liquid portion of blood, which is plasma, is at the top. And if you want to know what percentage of that is water, most of it is water, obviously.
So do they spin it again, Dr. Wilson, to
The blood plasma, so what do we find in the blood plasma? So most of it, again, is water, proteins, clotting factors, antibodies, complements. But the other material that we find in the plasma are listed here. Hemopoiesis. Hemopoiesis. So poiesis means production of.
production of blood?
Production of blood. That's it. So hemopoiesis, the adult production of 400 billion platelets, 200 billion red blood cells, and 10 billion white blood cells every day. So every day we're making this many cells. Looks like a lot. Okay, so hemopoiesis, the production of blood, especially its formed elements. So hemopoietic tissue then would be the tissues that produce blood cells. Okay, so where are blood cells produced? Where do we get our red blood cells, white blood cells? Right, so our red bone marrow produces all 7 of the formed elements. Okay, and then throughout development you may have other areas. The yolk sac, for example, during development. The liver, also during development, but it stops at birth. And the spleen remains involved with the production of lymphocytes. But all in all, the red bone marrow makes all of the types of blood cells. All right, producing red bone marrow. And they are short-lived tissue cells. So most of our cells, when our body is making new cells, remember most cells come from other cells. The cells just undergo mitosis. But our blood cells do not. The blood cells that we get again come from the bone marrow tissue. So the blood cells that are circulating do not undergo mitosis, in other words. And we'll see why, especially with red blood cells, they don't even have a nucleus. So they cannot undergo mitosis.